Hi, Brandon Clayton here, the Algebra Guy. Today our discussion will be how to solve quadratic functions or quadratic equations with the graphing calculator. Now you don't want to miss this one because when students see this one, I usually save this one for last because once you figure it out, a lot of times you want to go straight to the calculator. And I started with the more basic ways of factoring, quadratic equations, some of those other methods, the square root product, the property of the square root. So we did a lot of those methods by hand so you can understand it better. I'm going to look at graphing it on the calculator and just using some of the calculator tools to solve today. So let's get to our questions. By the end of this video, you'll be able to solve quadratic equations having real solutions by none of these, but by using the graphing calculator. No, that's not an actual TEK. I'm throwing that one in as a bonus. Because we get to use the calculator on this test, so please take full use of it. For other students around the state are definitely using it, you need to know how to use it as well. So let's jump into it. I'm going to jump straight into star problems today because there's no need to really practice anything. We've already done most, if not all, these problems before, or ones very similar to it. I only want to show you a different way of working them using the using a graphing calculator. So here's our first one. The total number of seats in an auditorium is modeled by this function, 2x squared minus 6x, where x represents the number of rows. How many rows are there in the auditorium if it has a total of 416 seats? So for the most part, I'm going to show you how to work these using two methods. Graphing them on the graphing calculator, which I love because you visually get to see what's going on. And there's a tool where you can just literally plug in the certain numbers and get the right answer. So let's see if we can explore those today. So I'm going to take out my calculator. If you have yours with you, I would encourage you to practice as well. Some of you may not have the exact calculator I have. You may just have graphing features, so you want to pay attention to everything that I'm doing. All right, so what I'm going to look at first is the idea of graphing this. So when I say we can rewrite this as 2x squared minus 6x, and this is going to equal the total number of seats, 416. And we want to know x, the number of rows in this equation. So all I did was put 416 in place of f of x, which represents the number of seats. How many rows are there? So what this equation is really saying is this side is equal to this side. Where do they cross is really what I should be thinking about. So let's see if we can explore that in the calculator, and bear with me a little bit because sometimes inputting in the calculator takes a little bit of manipulation. So I'm going to input this and I'm going to show you every step, even to the point where I'm inputting the actual equation. So what I'm going to do is put in two equations because literally there's two equations here. There's this side, and we want to know when this side is equal to this side. So you can look at it this way, or you could have put it in standard form and you could have written it. Let's write it in standard form. You could have written it 2x squared minus 6x minus 416 equals 0. And that would have been fine too. Matter of fact, we can explore both of those options. And there's not a whole lot of need to do a ton of problems here because they're all going to be set up the same way. So you're going to see me take quite a bit of time on this problem. I may skip a few because the principles are established. So one of the ways we can do it is set this side, graph this side, we press enter, and there it is. And we can graph this side, 416. How do you do that? We're going to press tab. Oh, by the way, when I graph this side, one of the common mistakes students make is instead of putting a minus sign there, they may confuse it for this negative sign. The calculator does treat those differently sometimes, so be careful of that. Matter of fact, I think if I put negative there, it wouldn't have even worked right. So this is minus 6x. Yes, we know that it's the same thing as adding a negative, but don't say 2x squared negative 6x. It needs to say minus. So keep that in mind. All right, so we want to get another equation by pressing tab, and we're going to press 416 because that's our other equation. We're really saying y is equal to 416 and y is equal to this. When are they both going to be equal? So I press enter and I don't see anything different. Why not? Well, it's 416. Look at the parameters of my coordinate grid. It's going up to 6, went to negative 10 and 10. So my goodness, it's probably not here. Now, knowing where 416 is helps me a lot. But I'm gonna say, what if I didn't know? What if you're just brand new to this and you're like, I have no clue where this graph is? Let's see. One of the things that sometimes helps me is if I zoom in on the graph and I do a particular zoom called fit. So I'm gonna say, try to fit this graph into your screen. So it tries to fit most of it there, but it didn't quite get it. So I'm gonna pull this graph down because I believe it's up here something. There it is, right there. So I knew it was up there somewhere. Now, another way you could have done is you could have just zoomed out, right? So you could have zoomed out, you could have picked where you wanted to zoom out, and I said I'm gonna zoom out here, and there you go. So zooming out helps me pull back the whole picture like that. That's a very important skill because, again, I've seen a lot of students have the right answer right in front of their faces, but because they didn't know how to use the calculator tools, they couldn't get to their answer. So now here's the second part. I graphed both of them, and now what? Now you need to know what to look for. So we need to know that we're looking for the intersections of those two equations. So when does this side intercept with this side? In other words, when is this side equal to 416? And we know they're equal at this point and at this point. So at those 2 points, they're equal. What do I mean those points? Those intersections where that red line crosses the blue line. So what is the x value where they cross? Oh, it's hard to kind of see. I can count 1, 2. Now these aren't counted by ones maybe. I'm not sure. Well, you know what we can do? There's a feature in the calculator that lets us analyze the intersection. So we're going to analyze this graph, and guess what we're going to look for? The intersection. And they're going to ask you for a lower bound or an upper bound. What they're really asking is just give us the lowest and highest of where you think it is. So let's take this point here. We're going to click to the left of that point, click once, and we're going to click to the right of this point. We click again. And by doing that, I'm able to see at what point they intersect. And I'm gonna do the same thing for the other side. And I'm gonna click to the left, click to the right. And it doesn't matter that you start from the left or right. So when I do that, I get negative 13. At negative 13, there's a 416, and at 16, there's a 416. Voila. So now we can see where they intersect when x is both of those. Now look at the answer choices become extremely easy. It's so exciting to do it this way because look, it's so simple. Now I can see that my answer is clearly going to be 16. Why not negative 13? Because can you really have negative 13 rows? No, that's not going to make sense. So the positive answer is correct. Now I'm going to explore other ways of working this using this same problem. So let's delete what we have. I'm just going to open up a new document. Don't save it. And I'm going to go to my calculator this time. So just my calculator screen. Another way I could have worked it is go to algebra and polynomial tools, and we can find the root. What do you mean by root? Okay, so root is where you have an x-intercept or a solution, a zero. Those are our roots. So I'm gonna look at that here in just a second. So degree 2, why? Because our highest exponent is 2 and we're dealing with real numbers. You're not going to usually change that. And here they're asking for A, B, and C in essence. What is my A? What is my B? What is my C? Well, my A is going to be 2, and this is in standard form, by the way. My B is going to be negative 6, and my C is negative 416. All we're going to do is plug in those values where you see the A2, the A1, and A0. Is so simple. Let's see if it works out. So we got a 2. They should go here, and we have a negative 6, and I'm going to make sure I push the negative 6 here. And lastly, we have a negative 416. Negative 416. And I press OK, and they said this is one way you could have written it if you wanted to, but you don't have to remember that. And look at this. Unbelievable. They tell us the two solutions are negative 13 and 16. Can it get any easier? I feel like I'm cheating, but they let us use a calculator that can do the work for us. So if you know how to use a calculator and understand what's going on in it, you're home free. So either graph it or put it into the calculator like this after putting it in standard form. So if I were to put it in the calculator like standard form, what would it look like if it wasn't equal to 416? So let's say I put 2x squared minus 6x minus 416. So let's just say we didn't put the 0 in. We push enter. And where is this thing? I can't see it. So remember what we do. We're going to do our windows, and we're going to fit. That's what I like to do first. I'm going to fit this graph, and I kind of can see where it is now. So I'm going to kind of maneuver. I'm going to zoom out a little bit, and there we go. So now I can see what's going on with this graph. Now, what are we looking for since we set equal to 0? So we're no longer interested in it crossing at 416. We're interested in where it crosses at 0. And what is 0? 0 is going to be your x-axis. This is y equals 0. Instead of y equals 416, it's y equals 0, this x-axis right here. Matter of fact, if I were to press tab and put a new equation in, and I just put 0, guess what line is going to highlight? Yep, you better believe it, the x-axis. So now I'm looking for what's called the roots. And I'm going to write this out because this becomes very important when solving equations. So we're looking for, when it's set equal to 0, we're looking for these points right here. You know, some remember it by an acronym called ROCKS. ROCKS. That means the roots. I'm going to do a different color. We talk about roots. X-intercepts, solutions, and I forgot what this, solutions, zeros. I must have put something wrong. So 0 is what I mean. So 0 is the other one. So yes, it's supposed to be, it's probably RXZS. I don't remember. Obviously, I don't use this one that much. But if you wanted to remember, there's 4 ways: roots, your x-intercept, solutions, and zeros. And I feel like I need to write that cleaner. But hopefully you're hearing what I'm saying pretty clearly. X-intercepts. So just include the Z in there, RXS, but you also include the Z. Roots, intercepts, and solutions. All right, so this is what these will be referred to. What are the roots? What are the solutions? What are the zeros? So how do I find that? I'm gonna find it in a very similar way that I found the other one. Actually, I want to pull it back up, my problem. And this time though, I'm going to do, we could analyze this graph, and this time we can look for zeros. Instead of intersection, we could look for intersection because we actually do have 2 lines here, but we could also look for zeros. And I want to look for zeros. I want to actually take away this last equation, x equals 0, because we really don't need that one. And I want to show you we can look for 0. So I'm going to delete that right there. Now we just have this, erase these points, and we're going to look for 0. So to do that, we're going to do menu, analyze graph, and 0. So we're going to do it the same way we did an intersection, and look for about where the point is, and click to the left of it, and then scroll and click to the right, and there it is. Do the same thing to the other side, left and right, and there it is, 16, 0. So there's many ways you can get to your answer. So I don't think we need a ton of problems because they're all work about the same way, but I will do at least one more. So let's click through and see which one. So this one, again, you can set up as a graph and look for the zeros. I can do that real quick. So let's erase this. Let's say, what if we put 1/3 x squared? So 1/3 x squared minus 3. And there's our new graph. So look how it looks. I'm gonna go back to standard zoom. So let's go zoom. Let's go by standard just to where it normally looks. And there it is. I can see it a lot better. And I can actually see what these intersections are going to be. So it looks like there's going to be 2 solutions, or zeros, or x-intercepts, however you want to call it. But which one do we want? If we're filling in a blank, it says record the what? Record the positive solution. So that'll obviously be 3. Now, if you don't want to guess here, you may be thinking, is that 3.1, 2.9? Again, I would just say, go ahead and analyze the graph for 0. Go to left and right, and there it is. So you can be sure that you're getting the right answer. All right, let's look at our next one. What are the solutions to this one? You can literally put this one in the same way. So let me see if there's any others. All these, you can put both equations in on both sides and look for where they cross. And this one is asking, they give you the equation, but they say, what if it was this is equal to 4? I want to do that one. So I'm going to do 2 of these. So I'll do this one. Let's do this one. So 2 ways you can do this one. You can subtract 32 and set it equal to 0, or just leave it like this and graph both sides. I'm going to go ahead and we'll graph both sides. Actually, no, I'll do 1. That makes more sense. Just for ease purposes, I'm just going to rewrite it so that I subtract 32 on both sides and that equals 0. So now I can just put this in and look for my solutions, because that's more common for us to do anyway. They'll ask us for solutions. So let's put that in. I'm going to go up to my first equation and delete that so it doesn't pop up again. And let's see if they'll take me putting this in just the way it is. 2x minus 7, and that's all squared, minus 32. I don't have to say equals 0. So there you go. I only see one line. Looks kind of weird, so I'm going to zoom, do a standard zoom, and I still can zoom. I'm going to do a fit, and I can see more now. So when I move it over, I can start to see a little bit more. So there's one here, and there's another somewhere here, and I can count it off. But why count when they can tell me exactly what it is? So I'm going to look for the 0, go left and right at that point, and it's 11. So now I know I have solutions at 3 and 11. So all this 7 plus or minus square root of and all that stuff is not even bothering me, because my answers are staring me right in the face. How easy is this? This is a question that is definitely going to get correct on your test when you set it up this way. And again, you could have solved it, put it in standard form, and use the calculator feature where you put in A, B, and C. But this seemed a little bit easier and faster for this particular setup. That's why I chose that one. This is a similar problem. Just put both equations in or subtract 18 and find the solutions. But I wanted to look at this one because this one was a somewhat missed problem. They gave you the equation and then they said, what are the values of x when x squared plus x minus 6 is equal to 4? What happens when it's equal to 4? So they gave the equation, then they said, what about when it's equal to 4? And more people missed this than I was surprised at, because I didn't think that many people would miss that one because it made sense to me. So let me make sure it makes sense to you. So what they're saying is that we have this equation right here, x squared plus x minus 6. Let me write it bigger up here. X squared plus x minus 6 equals negative 4. So we have this equation, and that's this parabola right here. And then we really have another equation that says y equals negative 4. And y equals negative 4 is simply a horizontal line going through negative 4. So when I think of it, I think of this line. Let's see if I can draw a straight line. I think of a straight line going through negative 4 like this. And what I've become curious at is where they both cross, where that parabola crosses those lines. That's my solutions at those points. And it becomes easy just to visualize without even any calculator tools that this is going to be a negative 2 and 1. So negative 2 and 1 without really, I don't have to put this in the calculator. There's really almost nothing I can do. But if I wanted to do something, I could put it in standard form and set it equal to 0. So we could add 4 on both sides and say x squared plus x minus 2 equals 0. And now we can analyze this as much as we want to. We can put it in the graph, or we can put it, let's try something different. Let's put it back in this piece here, this polynomial tools, find the real roots. We got degree of 2. So we have an a equals 1, b equals 1, and a negative 2. So we're just going to put in 1, 1, and negative 2. And press OK. And let's see what happens if you press enter. Look at that, negative 2, 1. Negative 2, 1, just as we saw when we visualized it on the graph. So please use your calculator. I know it's so sweet that it feels like you're cheating, but you actually have to know how to use it to get this right, because thousands of students have it, but still having it doesn't mean anything unless you know how to use it. So that's why I created this video. So please use your calculator. All right, that brings us to our conclusion. we solve quadratics having real solutions by using our graphing calculator. Mostly using two ways, a graph and this feature in the calculator that allows us to plug in A, B, and C. Thank you for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.